Good afternoon, good day, good morning, colleagues, or good day, colleagues, good afternoon, colleagues. hmm And it's true that we're going to talk about some experience that we have concerning teaching such an abstract discipline as systems engineering, so in IT disciplines in two colleges. Yeah, one is Bauman University, and the second is St. Petersburg Technical University. And there's my co-author who couldn't make it today, so participated, Mr. Volosyuk, so participated in the development, and so he shared with us how it's done in St. Petersburg. So what do we get? So why do we have? Why did we arrogate upon ourselves the right to talk about it? Because I teach since 2013, I already have several scores of students graduated, masters. They earned their master's degrees and they studied this discipline, and so then they graduated successfully. And organizationally, I'm a consultant of the master's systemic analysis program that we do at the computer system in information and management systems course. And I'm a certified coach, Luxoft. And Alexander has a vast experience, so he specializes in ergonomics and psychology, and the psychology of focuses on it of a certain special psychology, special tasks, specific tasks psychology. And so he has very good experience in dealing with the bachelor's student, not the original, so the second course, the third course, so sophomores, so the beginning. Um, so then he is good at teaching at for the first, second, third. So actually we cover everything. So from course one from year one to year five. So I will talk about the colleges that we teach. So some may not know about our colleges. So then we'll talk about my own experience of teaching. So at the senior courses, the junior courses, so the senior courses, more demands and more requirements because they have every right in accordance to the two-level system. So they are finishing their education, they can go to any industry, and because they are fully fledged, they are supposed to be fully fledged engineers and professionals and with skills, and so then I will share you how we managed to cross a snake and a hedgehog in our discipline, because it's mostly for engineers, for any information, computer systems, networking, IT systems, telecommunications. So how just we put it all together into one melting pot, and because we cannot teach the classics, systems engineering, because it should be quintessence and it should be just a mixture with it's convergence of different notions. So the notions of life cycle and etc. So we need just to put it all together. So the classical education, methodology, skills, models, and organization, design of the systems, systems management, etc. This all just we need to put into one thing, and so use the big mixer and come out with certain new type of discipline. And so we'll start with the beginning. So now many people who do not know much but very highly qualified, and the teachers. This is they don't know what system engineering is. So when you give the old name, systemotechnica, which is system engineering, okay, oh, now I understand. So then the coin drops, and the older teachers understand. Oh yes, now I know what system engineering is from the Soviet times. And so, but now they changed this systems engineering approach. And so that's why the meaning. So there was the system engineering in singular, right? And now, so that was back in the Soviet times, so system engineering. So now they're talking about systems engineering. So this is the plural form now. And so then, what can be covered by this notion of systems engineering? What's a complex system? So while in the 50s and the 60s, so it was some kind like an radio location system. So then radio relay system, or systems, defense systems, mobile systems. But now it is a traffic control system, for example. So when a radio relay system is just a tiny little cell, and used to be this mobile radio relay station was in the 50s and the 60s. Now just a small part of the bigger traffic control system. So the complexity level is rising, and the challenges that we face and is getting more and more difficult. And in the 90s, for example, everyone was happy with some perfunctory knowledge of the unified processes, and that was sufficient to put together very complex systems, including the systems of the enterprise level, big corporate systems, federal structure. But now that's not.
Today it's different. It has changed. The requirements evolve. We have different stages of development, and that is all very important. And one more interesting trend is as follows. This is the way we call the documents were called. ISO started calling them systems and software engineering. So as we can see, 5 to 7 years ago, two worlds are merging. Today we see few physical systems that could be interesting for designers. Many systems become computers. A motor car is becoming a computer, a camera is a computer, a fridge is a computer, a watch is a computer. So today, living in a complex cyber world and realizing that IT requires the purpose, why we're doing something and what for. If we don't have such a goal, a target, most often we work for a certain customer, a, an enterprise, a business. So we have to work with such an enterprise as a system, a peculiar system, different by organization and managerial methods. All this makes such disciplines very important for bachelors and for masters, for bachelor and master courses. So everything around us is a complex system, and those systems surround us, and we have to adapt to them and manage them, making them move in the right direction. Now, these are the universities that you know, and the facts. The Bauman University is one of the few that has a status of a national research institute of technology, which gives us a wide range of opportunities in our curricular, in our research programs. We do not just take what is provided by somebody else. We develop such programs and curricula and on our own. It's a challenge, but it's a good, comfortable situation. While when we are the leading technical university, IT university in Russia, and I've been dealing with that for 15 years. It's quite exciting. We can give the students what we think right. And we do it quite openly. We can do it without violating any legal requirements. We fully comply with the legislation, and we do what we think right, what we deem right. Besides, well, we are a strong number one technical university in Russia. As for LETI, the St. Petersburg University, one of the oldest in Europe, which has the largest focused campus in St. Pete. Of course, the state university is bigger, but LETI, the electrotechnical department, is one concentrated campus. while the St. Pete State University's campus is distributed, Alexey has one consolidated campus, the big one with 8,000 students, 16, sorry, 8,000 students. That is my experience, which is closer to me. My experience started in 2013-14, that is academic year. We have graduated and train now about 50 students, two groups of 20 plus and one group of 11 students. Uh, so I deliver not systems engineering but methodology of systems engineering. This is new master course with better and precise definition. From the very first days, we focused on convergence of system engineer, software engineering. We provide fundamental knowledge about what is a system, where we are, how we work with systems. Then we move on to the rails that lead us to software development and using various technologies, software development technologies. We're not talking about construction, uh, aerospace. We are dealing with software in general. So we look at the evolution of our industry, we look at international standards, Soviet standards, Russian standards, and a real industry-based expertise. Oh, well, if we resort to facts, these are the disciplines, the departments that teach, and the place of the courses within the 2-level and 3-level systems. Now we have uh, bachelor's and master's. We don't have the previous system. It is maintained in some limited areas. As for Leti in St. Petersburg, experience was generated by ASOEU department, by several professors, including professors, and Dr. Alexander was a professor and is a professor now. He teaches and he accumulated departmental experience. He talked a lot to various specialists while preparing for this presentation. And as for the challenges are as follows. The first one, well, I focused more on systems engineering, while Leti focuses more on system approach, because bachelor's and first year students have to get fundamental knowledge, basic practices in a certain systematic environment. Each discipline demonstrates its part of a bigger picture. It's like a Lego or a puzzle. Each discipline is part of the puzzle, and the task is to see the general picture. And that is the task that a student must solve, the problem that the student must solve. Bachelors learn for 4 years, and it's very difficult for them within that time to stop and meditate and look at the general picture at a high level of abstraction, and to look at systems, for example, social, technical. In the master degree gives you that opportunity. We have systems engineering, and it provides you with a big picture. But even in 11th semester, uh, in 11th semester, we have a small and not with a little practical experience. It's not an easy thing to generalize and see the big picture. For example, the students call it we build sites. not portals, not huge complex portals, but just site building. It's easy, it's not complex. Yes, there are some systems, but the level of complexity is not very high to realize the value of practices and methodologies that this program wants to deliver to students. For many students, this discipline remains abstract, an abstract one, and the more so that we say about systems and software engineering. Well, it helps a bit when we give assignments, IT assignments, and speak about software. We make the problem more practical, even for those who didn't realize the abstract nature of systems in general. Not all students and not always being technical specialists, well, not all of them can comprehend the general concepts. The notion of system can be defined in different ways. There are several schools of thought that agreed that a system is this. But if we don't believe that, we cannot touch and feel the system. We cannot have a look at the system. It's a notion rather than a physical object. This discipline lacks mathematical apparatus, formal apparatus. If we look at the set of lectures, at the core open lectures, at open international resources, we shall see tables sometimes, or diagrams sometimes, but we shall hardly see even a dozen formulas, mathematical formulas, because the discipline is very generalized. It generalizes practices of complexity management and risk reduction. Systems engineer is risk-oriented, I believe. So we shall hardly see at least a dozen formulas that we could learn and say, I know the main laws, the main patterns. We don't have such. And one more problem that I started with is the lack of practical experience. If you will look at the international education related to software engineering and computer science, you will see that masters in the West are not taken from bachelors, but they should be bachelors that have at least 2 to 3 years of practical experience in industry. And system engineering as a discipline that turns students into a system architect who can manage an end-to-end complex system and control the level of risk, then you will see that the student must be a bachelor, then will have a few years of practical experience, and then only start learning, start with his or her master's program. So, system engineering is closer to economic informatics or business informatics, and it can raise such questions as enterprise architecture, process modeling, and so on. Case 1, it's about MGTU, the Bauman University, which describes the main notions that we get the students acquainted with. These are the central notions: life cycle, architecture, and the duality of systems engineering and software engineering that we have discussed. When we speak about life cycle support systems or life cycle management, well, it's not very close to us, not very interesting to us. We see, why do we need product life cycle? Yes, if you are a architect, you build houses or launch missiles, that is true. But we have our own tools. Our tools are in the middle. It's application lifecycle management. It's a complex of systems which include versioning, source code management, automatic testing, then pipelines of continuous delivery, continuous integration. We have our own toys that are important for us for successful implementation of our projects. But if we look at how this work is organized in LETI in St. Petersburg, they focus on system approach. They have first-year students, second-year students. Uh, they try to look at particular knowledge pieces and trying to build a general picture out of them. But they are given specific lectures on specific disciplines. One more unique notion is, well, we have a separate discipline here, but LETI doesn't have it. And they have to work differently, providing appropriate knowledge at different disciplines, at different lectures, and that is good. Uh, because when we speak about the same thing while delivering different lectures in different courses, you repeat one and the same thing, and people remember it, people believe it's important, and they will never ask a question, why do we need that? That is not interesting, and so on and so forth. Students should see the value of understanding of that general picture. And what did we uh, learn? Well, first of all, a hypothesis to the general approach to your course. What are the main uh, principles? We think we have to regard the life cycle of system from designing, even from requirements, from the general concept to practical implementation and operation and utilization after the end of the life cycle. This approach is used in many Western manuals, much more numerous than in this country. We have not many textbooks and manuals in this country in the Russian language. Besides, we saw that our hypothesis about inserting system approach into different disciplines and demonstrate ideas of engineering in systems engineering courses, it works. Yes, it works well. Besides, we had to take into account humanitarian and abstract nature of the course, which is not typical of technical university. We developed a special control and measuring tools. We don't have problems like those of mathematics or physics. How can we check the skill of drawing a diagram of a cycle? Well, this is a minimum level of competence. The main focus in that set of materials is on solving practical, well, on preparing documents or preparing artifacts to support an imaginary system. And we can talk about that separately. I think we shall publish an article about that in the near future, or maybe we shall talk about that at the next year's conference. What are we going to do next? What are we doing now? Where are we moving with all our experience? And today, as I said, we are building the whole area of the second higher education. Maybe in the first higher education we shall do the same. It's system analysis and architecture of information system. And we started developing a lecture set, Introduction Systems Engineering. This is a preliminary name. Perhaps in spring or in summer next year, this text is going to be published because it is based on real tested and materials, and because of lack of our training materials, that will be a popular set of lecture. So I have 47 seconds to go. So it's time to ask questions. Questions, please. Thank you, Alexey, for your presentation. If you have any urgent questions, despite the coffee break, which is going on, well, we are behind schedule, unfortunately. You know, I have a specific question. In systems engineering course, well, I've heard long ago that people take charts and pictures better than text. Can you prove that? Do you use charts and pictures and images? Can you confirm that people take images better than text? Well, when designing systems, when designing systems, yes, of course, you are quite right. An image is taken better than a text. We have a lot of formal graphical modeling and designing languages. Can you give me a link to uh, uh, where I can read about that? It's everyone speaks about that, but can I read any psychological work that could confirm it scientifically? Well, in order to give you the answer, let us exchange our mails and phones, and I'll give you the answer later. As for the languages, yes, the kernel, the core of that discipline is engineering practice, and a person, a student, uh, must know IT architecture programming language, UML, SysML, OCL, and programming languages at the enterprise level, BPML, Archimate, and others. Of course, graphical representations are more clear because they are based on certain meta models, and they can be syntactically strict and can be validated, precise, and so on and so forth. Or, for example, they can be used for orchestrating business processes in the BPM systems. It's a very live and scientific approach. Thank you very much. Are there any more questions? Thank you very much indeed.
Спасибо.